let's go over one more amplifier analysis. And this time we're going to analyze a PNP transistor. And we're going to assume that the voltage between the emitter and the base, the VEB, is equal to 0.7 volts. And the beta for this transistor is equal to 100. And we want to analyze the circuit and find the voltages and the currents in all nodes and branches of this PNP transistor. I'll start by designing the PNP transistor and writing all the relevant information into this design. We know that the VEB is equal to 0.7 volts and the beta equals to 100. All right, so analyzing PNPs is no different than analyzing an NPN, just that the voltages are subtracted slightly different. So our VEB is now VE minus VB. And we know that our VB is going to be equal to 0. And with that, we get a VE of 0.7 volts. It's always good to highlight your answers. Again, it's easier if this is being graded. It's easier to follow. All right, we found our VEB. Now let's go and find the current that flows through the emitter. We can apply Ohm's law through that 2K resistor. And we know that the current flowing through the emitter is going to be equal to 10 volts minus VE divided by 2K. And we get a current of 4.65 milliamps. We need to make a couple of assumptions. Let's assume that the transistor is in active mode, and then we'll confirm that assumption later on to see if it's a good assumption. In active mode, our beta is 100. So the current that flows through the base relates with the current that flows through the collector by this formula. And the current that flows through the emitter is equal to that IC divided by alpha. Alpha is related with beta and it's equal to 0.99. So with these I know IE, I know the current flowing through the emitter. So the collector current is 4.6 milliamps. All right, so I just write the collector current over there. And knowing this, I can now apply Ohm's law. Let's just write the current at the base. Now that we know the collector, we get 46 microamps. I could have highlighted things at the end. I'm just doing as we go because we use these values as we move forward. And let's now apply Ohm's law on that 1K resistor, and the voltage at the collector minus 10 is going to be equal to the current through the collector times 1K. Rearrange this equation so I can find VC, and IC is in milliamps. It cancels out with the K of the resistor, so I can just say times 1 and minus 10, and I get a VC of minus 5.4 volts. All right, so now it's time to just see if the assumption that we made, the active mode, is correct. And the PNP transistor to be in active mode, the voltage at the collector needs to be less than the voltage at the base, and the voltage at the base less than the voltage at the emitter. And this is correct. The voltage at the collector is minus 5.4 volts, voltage at the base is 0 volts, and the voltage at the emitter is 0.7. So we're good in active mode. And the last thing that we need to calculate is VCE, or in this case, sorry, VEC, because it's the PNP, and it's VE minus VC. We know VE is 0.7 volts, and VC minus 5.4 becomes positive, and I get the 6.1 volts of VEC. Now let's go and simulate the circuit. I'm going to use first false stat. And you can see that the currents are pretty much similar to what we got in our hand calculations. The VEB is different for this transistor, is not equal to 0.7. That's why the values are slightly different. We have our VC of 6 volts. Now I'm measuring VE and VC and VB. And you can always put some text. So I press the keyboard T, and I can put some text around to make my, so I know what I'm reading. And here you have the system with all the currents and voltages simulated in false stat. Now let's go and use multisim. Let's add some measurements here, some volts and currents around our circuit, so then we can simulate and validate our answers. So remember that this transistor, this PNP transistor, the VEB is also different than the one calculated by hand, but the voltages and currents are pretty much similar to what we found before. And here you go, the final answers. So all the currents, all the voltages, and the PNP is working in active mode, and this should be the answer for this exercise.